Well, hello everybody. Hey, sorry I missed today, or sorry you missed, whichever was the case. Your tests are graded and in Power School. I will give those back next time. So in case you missed today or in case I did. Hey, what I need you to have in front of you, have your class notes for section 2-1. It's an overall easy section, but there's some vocabulary kind of things I need you to get familiar with. And then the words domain and range show up. So I'll have to make sure that you understand what I mean there. And then function notation, which you've probably seen in Algebra 1, also shows up. But guys, I'm just going to kind of roll with this. I'd like for my video to only be about 20 minutes long. So I'm going to start rocking and rolling these. Guys, the first definition, this is not on your class example sheet. But the first definition I want to talk to you about is the definition of a relation. And a relation is simple. It's any set of ordered pairs. Some books call it a mapping. Some people call it a chart. But in any relation, it's just a bunch of ordered pairs. Now, here comes some terminology for you. The domain of any set of ordered pairs is simply your x values. So in this case, the domain for this first one would be the numbers 1, 2, 3, 4, 5, and 6. The range is simply the y values. So in this case, the range would be 5, 6, 4. I don't need to list the 5 again. I don't need to list the 4 again. I don't need to list the 6 again. So there's the range. So guys, the domain is simply the x values. The range is simply the y values. So I'm going to erase this one. If I pick on the second one, and I'm not going to do every one of them. I don't think we need to. But if I pick this one, the domain would be the number 6, 7, 8, and 9, the x values. The range would be the number 75. Notice the little things, just the notation, capital D for domain, capital R for range. This colon just means it's just notation, and then once again those cool parentheses. So that's the domain and range. We'll practice it here again on your worksheet here in a little bit. So the x value is known as our domain, the y value is known as our range. Now, a relation becomes a function. If and only if, that's what that IFF stands for, if and only if each element in the domain corresponds to exactly one element in the range. Now guys, listen to this story and tell me if it could happen in real life. On the first day of cross-country practice, I sent my guys 5 miles. On the second day of cross-country practice, I sent them 6 miles. On the third day, I sent them 4. On the fourth day, I sent them 5. On day 5, I sent them 4. And on day 6, which would be a Saturday, I sent them 6. If this could happen in real life, it's a function. So in this case, the answer is yes. This is a function. Here comes a goofy story for my next one. On the 6th day of my weightlifting plan, I benched 75 pounds. Not very strong there, guys. On the 7th day, I benched 75. On the 8th day, I benched 75. And on the 9th day, I also benched 75. It means I just didn't improve. But that could happen in real life. So guys, that is also a function. Now coming up is an example of one that is not. So kind of listen to the story. I'm going to pick on LeBron. In the 4th game of the NBA season, LeBron scored 11 points. In the 5th game of the season, he scored 12. In the 6th game, he scored 21. In the 7th game, he scored 8. And in the 5th game, he scored 15. Now before you say LeBron's so good and everything, and yes, that could easily happen, I want you to look at things again. Along the way, I said, in the 5th game of the season, he scored 12 points, and in the 5th game of the season, he scored 15. Well, something's got to give there, so no, not a function. So guys, the shortcut to this is it's going to be a function if your domain doesn't repeat. So check this out. I'm going to list the domain 4, 5, 6, 7, 5. Notice I have 2 5s. That means it's not a function. If I look at this next one, my domain is 1, 2, 3, 4, 5. This one will be a function. In this one, 1, 2, 3, 4, 2, not a function. So that's how you tell if it's a function or not. Now, jump over to yours now. What I'd like to do is state the domain and range, and then that's all I want to do on these. I need to change my direction. So on number 1, the domain is just the x value. So capital D colon cool parenthesis 0.5, 0.4, 3.1, 0.4. It's okay if you list that twice. If you caught it and didn't want to, don't do it. Now, right away, guys, I know this is not a function already. How did I know that so fast? 0.4 and 0.4. Now, the range will be the y values. 3, 2, 1, 0. So guys, that's all there is to domain and range when it's a set of ordered pairs. My number 2, my domain is going to be -5, 4, 3, -7. None of those repeat, so yes, this is a function. My range then will just be the y values. 2, -2, -11, and 2. You could list it or you don't have to. Same thing with number 3. My domain is going to be 0.5, 0.1, and 6. Since none of these repeat, yes, it's a function. My range then will be the y values. -3, 12, and 8. So guys, I'm going to bypass number 4 because it's the same thing as we've done. That way I can kind of get to some other things. Now guys, on number 5, notice these ordered pairs. They're just on a grid. So what I'm going to do is I'm going to list them for you real fast. I'm going to work from left to right. So I spy the ordered pair -4, -2, -3, 1, 0, 2, 0, -2 I meant, 1, 2, and 3, 3. There's the ordered pairs. Well, here goes the domain. -4, -3, 0, 1, and 3. Right now I know that it is a function. My range now will just be the y values. -2, 1, -2, 2, and 3. And like I said, guys, if you didn't want to list those twice, that's fine. But it's not wrong if you did. Now, number 6, I'm going to put a little twist in here. The domain of this, if I started listing all the ordered pairs, I could list them forever. So check this out. I'm not going to list that as domain. I would have the ordered pair 0, 2. I would have the ordered pair 1 something. I would have the ordered pair 2 something. Now there's a trick to this. The x values, the domain, notice that this thing is solid. It's continuous forever. Whenever it's continuous like that, your domain is all numbers. So your domain is all numbers. In interval notation, it looks like this. -infinity to infinity. This is weird right here, guys. The reason it's also negative infinity to infinity, it goes to the right forever, and it goes to the left forever. And you're thinking, well, wait a minute, Mr. Harris, that's up and down. My range is also negative infinity to infinity because it goes up forever and down forever. The domain, it went to the right forever and the left forever. Whenever it does that, it's the infinities. Now, number 7, this leads into what we're going to do next time anyway. On number 7, I picked some x values for you. Please note that I could have picked any x values in the whole wide world, but I picked -4. So guys, if you grab your calculator and go 1/2 times -4 minus 3, you will get the y value that goes with -4. And if you run that through your calculator, you're going to get -5. Remember, your domain is the x values. The range is the y values. Now let's run -2 through there. I'm going to go 1/2 times -2 minus 3. I'm going to run that through my calculator and get -4. Just to speed the process up, guys, when you run 0 through your calculator, you're going to get -3, -2, -1. So now let's graph these real fast. I've got -4, so I'm going to go to the left, -4, and then I'm going to go down 5, and there's a dot. I'm going to go -2, -4, 0, -3, and I put a wrong dot. 0, -3, that's looking better. 2, -2, and 4, -1. Now guys, this is a trick. This chart goes on forever, both ways. So technically this becomes this. So your domain is negative infinity to infinity. Your range is also negative infinity to infinity. So once again, guys, it goes to the right forever. It goes to the left forever. So hence the negative infinity to infinity. For the range, it goes up forever, and the left side goes down forever. So let's change that. It goes down forever and up forever. So you got to be careful with the graphs. Here's your number 8. This is called a parabola. We graph more and more of these coming up. So guys, once again, when you run this through your calculator, you got to be careful. Whenever you have a negative number, you got to put it in parentheses. So when you type this in your calculator, I'm going to go -4 in parentheses squared minus 3. And that's going to become 13. I'm going to then go -2 squared minus 3. And if you want to do that in your head, -2 squared is 4, minus 3 is 1. When I go 0 squared minus 3, I get -3. And then I'm going to get 1 and 13. So guys, when I graph this, I'd have -4, and then -13 is way up here. But I got -2, positive 1, 0, -3, 2, 1, and 4 way up here. And guys, you're going to get a graph that looks like this, called a parabola. Now the domain and range on this is easy but tricky. Look at the graph. Notice that it is going to the right forever, and it's going to the left forever. So my domain is -infinity to infinity. The range will be brand new to you. The littlest y value that I'm using happens to be -3. It starts down here at -3, and then it goes up forever. So my range will be -3 to infinity. It's a fancy way of saying the y values, the lowest that you're ever going to see is -3, and it's going to go up forever. So guys, just do your best on them. I'm going to clean them up again next class, so you'll see some more domain and range. Now, just a little thing that I want to show you too, called the vertical line test. If you look at a graph, and then if you look at a graph, if you can draw a vertical line and hit that in more than one